Okay, hello everybody. Good afternoon, all of you guys. I hope that you are very, very good. Your preparation is going very well. I hope that I am audible to you and also visibility is very clear to you. Please let me know if you have any kind of technical problem. Please let me know, guys. So, today it's our session number 18, right? And we are doing the classical thermodynamics, and successfully we have completed the. I think voice is clear to you guys. Video is also clear. There is no technical problem. So I think we can start the class. Due to some medical emergency, I couldn't be available at the 12 o'clock as it's our schedule, right? And I just came so at 12:25. So that's why I postponed your class, right? So sorry for your inconvenience, guys. Okay. So let's start our class without wasting any single minute. Okay, let's discuss the previous things very quick. So these are the, you can say that one question we have solved, which is based upon the Carnot engine. One, this is the important, you can say the important question, I must say, because in this question there is nothing given to you like in terms of the rejection heat or absorbed heat or temperature of the your sink or temperature of the source, right? Nothing is given to you, only you have the PV diagram. Through the PV diagram, how we can solve the efficiency of an engine, this is the way, guys, right? So this question is a very important and very, you can say, conceptual. So I hope that the solving of this question is clear to you. After that, we have discussed the reverse Carnot cycle. So Carnot cycle, what is basically the Carnot cycle? In the Carnot cycle, we are giving some heat, right? These notations are, you can see, these directions are different only. In the Carnot cycle, we are giving heat and we are rejecting heat, like to the sink. These are the you can say funda in the Carnot. What is the meaning of reverse? The meaning of reverse is only that just reverse the direction of the heats, right? The you can say the taken heat will be the, you can say, the released heat, right? That the, you can say, your motive will be changed now. Now your motive will be the heating effect, right? So reverse Carnot cycle is basically the, you can say, heat pump, you can say the, or in the other words, you can say heat pump is based upon the reverse Carnot cycle. After that, we have discussed the Clausius inequality, and for that purpose, we have taken the two kind of engine, reversible, irreversible, and by comparing their efficiency, we got to know that the closed integral of dq over dt is less than 0 for irreversible, right? And now after some time, I will solve this, that is closed integral of dq over dt, cyclic integral of dq over dt is equal to 0 for the reversible. So through the Clausius inequality, we got to know that cyclic integral of dq over dt cannot be 0. This is not possible at all. It is less than 0 for the actual, and if we'll take everything ideal, then it can be 0. That's it, nothing else. And with the help of this example, we calculated the direction and the magnitude of the heats. Okay, so I think this was the part which we calculated, guys. I hope that it's clear to you. Please let me know. Till this, is there any problem to you or not? Till this, everything is clear to you? Anyone? Anyone? Everything is done? Can we move forward? Can we move forward? Okay, great. Okay, let's discuss the next thing, guys, right? The next thing will be my entropy. Okay, now my next thing will be the entropy. So you heard about this term entropy. Okay, so first of all, let's try to understand entropy, right? Entropy, right? So first of all, that we have to figure out what is the entropy in all these things. Okay, let the entropy be aside, and let's understand one thing, that is, see, in general, in the initial lectures, I hope that you know what is the process. What is the process? So process is nothing, change in the state is the process. Change in state is process, right? Or very simple, right? Means you have one state. This is at this stage, there is a P1, V1, T1 properties, and at this state, if you are moving to this state having the P2, V2, T2 properties, this is the process actually, right? It is clear to you? Okay, now let's understand. There are some, you can say, the some examples of the natural processes are, if we'll take some examples of the, you can say, the natural processes. Natural processes, it means that we are not doing any extra effort to do any process. Okay, like if I'll say, I'll take the first example. If I'll say that I have two gas chambers. These are the gas chambers, let's suppose, and these chambers are connected through a hole, let's suppose. Okay, let's suppose at this side vacuum is created. It means this wall is closed position. Initially it is in closed position, and initially there is a gas which is filled into this chamber. Okay, if this chamber is filled with some gas, then this chamber has some pressure, guys, right? It is clear to you? Okay, let's suppose I'm saying it is P1, right? It is clear to you. Now tell me one thing, if I'll open this wall at the opening at this stage, what will happen? You will say, sir, we know that this gas is basically flowing from this direction to this direction, and this gas is occupying the space of this chamber also. Very good, clear. The pressure is going to this side, so now the volume which is gas is going to occupy, that is now more. It means that pressure will decrease. It means that this is the expansion process, right? It is my expansion process. And if this expansion is going into the a process where one side is at vacuum, that is called Joule expansion. Okay, Joule's expansion, right? It is clear to you. This is only the terminology, don't worry about that. So pressure will going to decrease here, that's why it is an expansion process, yes or no? So my question is that at what stage this pressure is going to the side of vacuum? You will say, sir, P1 going to decrease, and at some time the pressure of both the chamber will be equalized. So it is my, you can say, the chamber 1 and it is my chamber 2. So the pressure is going to decrease. Let's suppose after initial pressure is P1 and after decreasing the pressure is P2, right? It means that now after the opening of this wall here, this chamber has P2 pressure and this chamber is also at the P2 pressure. Initially it is at the P1 pressure and it is at the 0 pressure, right? It is clear to you. Now the pressure on the both side will be equal. Now there will be no flow of the gas from this side to that side. I hope it is clear to you, right? Or you can say all the forces are balanced now, so you can say that this process is in mechanical equilibrium. This process is in mechanical equilibrium. Why are you, sir, stating all these things? We know what is the mechanical equilibrium. Are you going to discuss the mechanical equilibrium? No, I don't want to discuss the mechanical equilibrium. My you can say aim to define all these things is that in the nature every process is, or you can say every process wants to be in the equilibrium, guys. Every process is going to that side which gives the equilibrium to that state, equilibrium to that system, or you can say the process. So in this process we did not apply any extra effort. The process is happening naturally. Now what is the direction of this process? Whatever the direction the process is, in this direction, see, the process is this process is going from higher pressure to low pressure. So this direction of the process is decided by what? It is decided by the equilibrium. So every process is going towards its equilibrium. Okay, right? Am I clear with this? Let's give another example, a very simple example. If let's suppose we have a hot coffee. Okay, let's suppose this is a cup. and a hot coffee is filled in this cup. What is the natural process? Can you guys tell me? Can you guys tell me what is the natural process occurring in this you can say scenario? Please say. Please tell me what is the natural process that is going to happen. Very good, Anushka. It is basically cools down with the time. Yes or no? Let's suppose that my atmospheric temperature is, let's suppose, 25 degrees Celsius, right? And let's suppose my coffee temperature is 50 degrees Celsius. Heat transfer will be there. Automatically heat will be transferred from the coffee to the surrounding, right? There is no need to do any extra effort. Yes or no? Okay, so it means that this process is going which side? The heat transfer from higher temperature to lower temperature to achieving the thermal equilibrium. To achieving the thermal equilibrium. When the temperature of the coffee and the temperature of the surrounding is same, the you can say process is basically stopped there. Yes or no? Is it clear to you? Done. If I'll take another example, let's take a last example. Let's suppose we have our two solutes and it is separated by a membrane, right? So yeah, definitely there will be a diffusion of the gas, right? It is clear to you. There will be a diffusion of the gas due to the concentration difference. Due to the concentration difference, right? So at a certain point of time, this gas is achieved its chemical equilibrium. So I take all the equilibrium, mechanical, thermal, chemical, right? All basically I discuss the equilibrium, which is my thermodynamic equilibrium, right? So you can say that naturally all the processes wants to achieve its equilibrium. So the reaction, the process always going to that side, which basically which side? At the equilibrium side. It is clear to you? Okay. Now, so you can say that it is also you can say the it can be the question of interview that on which side your entropy will be maximum. Okay, on which side your entropy will be maximum. So guys, in the you can say naturally when the process is achieving its at equilibrium my entropy of the system will be maximum. Okay, see, according to entropy is a hypothetical concept. First of all, hypothetical in terms of what? Or you can say it is not a physical parameter like temperature. Let's say temperature. Temperature is a property. Entropy is also a thermodynamic property. But we can feel the temperature, we cannot feel the entropy. We can see the volume, we cannot see the entropy. We can feel the pressure, we cannot feel the entropy. Right? So in this way, it is not the physical property which we can feel actually. Okay. So entropy is a method actually. So entropy is a method to measure the randomness of the system, that how the system is random, how much the system has the random arrangement actually. Okay. So according to Boltzmann, entropy is measurement of disorder in molecular arrangement of any system. Right? It is clear to you? Or you can say that entropy is degree of entropy is, you can say entropy represents the randomness in molecules. Okay, it is basically represents the randomness in molecules. So we know that if we give the heat, then randomness of the molecules will increase. It means the entropy will increase. And if I will release the heat, it means the randomness of the molecule will be decreased. It means that the entropy will decrease. It is clear to you now, right? So we can say that next point about the entropy is that it is thermodynamic property. It is a thermodynamic property that increase when heat is applied and decrease when heat is rejected. Okay. Also, remains constant when no heat exchange. So it is my thermodynamic property which increase when the heat is applied and decrease when the heat is rejected, and also it remains constant when no heat exchange is there, guys. Now we have to understand the entropy mathematically. Okay? We have to understand the entropy mathematically. So let's understand this mathematically. Okay. Please note this down and tell me that this is clear to you. After that, we'll move ahead. Okay, great, great. Now we will try to build a mathematical relation that okay, we understand, sir, that this is the measurement of the randomness of the molecules. So, and also we understood that the relation of the entropy and the heat is that if we supplied the heat, obviously the randomness of the molecule will increase, so entropy will increase, right? So we understood the relationship of the heat exchange and the entropy. Now let's try to build the mathematical equation so that mathematically we can calculate the entropy. Okay, so let's understand this. So for to understand this, I have to take an example of a reversible engine, or you can say the Carnot cycle engine. Let's suppose, guys, this is my source and temperature is T1. Let's suppose this is my sink. Temperature is, let's suppose, T2. There is a reversible engine, right? This is my reversible heat engine, and one is my any heat engine, right? Let's suppose I'm getting W1 work done from the reversible and W2 work done from this heat engine. Again, let's suppose it is my Q1 dash, rejected is my Q2 dash, it is my Q1, it is my Q2. Okay, very simple. I can write the efficiency of the reversible will be 1 minus Q dash divided by Q1 dash. If you have any problem at any point of time, just tell me, okay? And efficiency of this heat exchange is equal to 1 minus Q2 divided by Q, right? So this is any heat exchange. It can be the reversible or it can be the irreversible. And this is the irreversible. This is the reversible. This is the reversible. It is fixed. So I think I can say that the reversible heat engine efficiency is always be greater, or this heat engine is, if it is reversible, then it can be equal to this heat engine. What is the value? 1 minus Q2 dash divided by Q1 dash is equal to 1 minus Q2 divided by Q1. 1 gets cancelled. 1 gets cancelled. This is the minus minus. So if you will multiply with the minus, then equality sign will be change. It is my Q2 dash divided by Q1 dash is less than equal to Q2 divided by Q1. I hope it is clear to you. And because this ratio is for reversible, so I can write this in the temperature ratio. This we already proved. So it will be my T2 divided by T1 will be less than equal to Q2 divided by Q1. Is there any problem? Is there any problem? Please let me know. Please let me know that is there will be problem, yes or no. If there is no problem, then write it and tell me. Write it and tell me. Done? Done? Okay, do the same thing, guys. Just first, do the cross multiplication. That is Q1 T2, which is less than equal to Q2 T1. If I'll divide with the T1 T2 both side, then my equation will be if I'll divide T1 T2 T1 T2, then it's T2 T2 T1 T1 gets cancelled, right? It is clear to you. And from this equation, and I can write that it is my Q1 over T1, which is less than equal to Q2 over T2. Okay, and this I can write this equation as Q1 over T1 minus Q2 over T2, which is less than equal to 0. Okay, right? And this equation we write already in terms of Q1 divided by T1 plus minus Q2 over T2 is less than equal to 0. Because Q2 is rejected, that's why it contains the negative sign. It is clear to you or not? Okay, done. It is clear to you. And in the similar way, guys, in the similar way that this can be written as sigma I1 to 2 Q upon T is equal to, or you can say less than equal to 0. Right? It is clear to you? Or so. And in the integration term also we can write that cyclic integral of Q by T is less than equal to 0. And here that this equal to 0, Q by T is equal to 0 when what? When this assumed heat engine is my reversible. If it is reversible, then it is equal to 0. If it is reversible, then it is less than 0. I hope that you got my point, right? And I already, sorry, it is my dq. If I write integration, then it is dq. It is clear to you or not? It is clear to you or not? It is clear to you or not, right? Done. Both the things are clear to you, reversible and irreversible? Yeah, Muhammad Anushka, please let me know. Are you okay with it? Yes or no? Okay, so just remember this: for reversible, it is equal to this thing. That's it. There's no need to remember these all. You can say the derivation, right? So last class equal sign was not there. Yes, last class equal sign was not there. Why? Because it is already assumed that it is my irreversible. Okay, in the last derivation, that's why I repeat this derivation, beta. That's why I repeat this equation, right? So in this, in the clashes inequality, it is already assumed that it is my irreversible. If it is reversible, then it cannot be equal to 0. It is always less than equal. It will always less than 0. So I told you yesterday also that the dq over dt equal to 0 for reversible. And see, this sign is not, you can say that this thing is not in this derivation. This thing is not there in this derivation. So in the yesterday class also I told you that I will let you know that how del q over dt equal to 0 for the reversible. For irreversible, we know this. For irreversible, we you can say that drive all these things, right? So for irreversible, we can tell that this thing is true, right? And this thing I just write it and told you that yeah, in the coming lecture I will drive it that how for reversible it equal to 0. Okay, this is the difference only, right? Now this is my any heat exchange. I'm not saying it is reversible. I'm not saying it is irreversible. I'm saying it is any general heat exchange. Or if it is reversible, then this will be true, and if it is irreversible, then this will be true. This will be true, right? And this is my, you can see the case. Okay, done. It is clear to you or not? Now see, now entropy discussion is continued, right? Okay, so let's suppose, guys, I have a TS diagram. Let's suppose it is temperature, it is entropy, and this is my point 1, or you can say the state 1, and this is my state 2. And I just make the some path from 1 to 2. From 2 to 1, there is 2 paths. One is this, and another is this. Another is this. 1 to 2, and from 2 to 1, you can go through these 2 paths. Let's suppose it is my A, it is my C, and it is my B. So I have 3 different paths. Okay, 3 different paths. 1, 3. Okay. Yeah. So we know that. Yeah. So all these paths are reversible. All these paths are reversible. Okay. And we know that cyclic entail of dq. Actually, I should write this thing as. I should write this thing as in proper notation. It is not d, you know, because it is my path function and it is not the exact differential. It is denoted like this. You can also write this. You can also write this, guys. Okay, this can be. Okay, have not diagram. Just give me a second. It's gone, I think. It's gone. Okay, no worry. Okay, so make the TS diagram. And this is my state 1. This is my state 2. And we have 3 paths. From 1 to 2, you can go like this. And from 2 to 1, you can go with any way. You can go like this, or you can go like this. It is my A, it is my B, and it is my C. And we are discussing the entropy, right? Okay, for the closed cycle, del Q over dt is equal to 0. It is for reversible. We know that, right? Okay, see, guys, do one thing. Just take the process 1A2, and 1A2 is also reversible. 2B1 is also reversible, right? These processes are reversible. 1A2 and B1. 1A2 B1. I'm taking this path, right? This one and this one. Okay, it is clear to you. And this cycle is reversible. This thing is reversible, right? And we know that for reversible, del Q over T equal to 0. Can I write this for, it is cyclic, it is integral of 1 to 2 it is my del q over t for the process A from 1 to 2 for the path A, plus from 2 to 1 del q over t for the path B is equal to 0. Right? I just apply this inequality. Okay? It is for 1A to B1. Right? It is clear to you. Now take the another path 1A to C1. This is also a reversible process. This is also a reversible process. So I can how I can write the integration? Very simple. From 1 to 2 del q over t for the process A, plus from 2 to 1 del q over t for the process C. That this addition must be 0. Let's suppose this is my equation number 1 and this is my equation number 2. Done. Just now subtract the equation from just subtract the equation by subtracting equation number 1 minus 2. What is the you can say your equation? So it is my, I write both the equation from 1 to 2. It is my del q over t for the A, plus 2 to 1 del q over t for B, minus integration 1 to 2 del q over t for B, plus, it is plus. Now after subtracting, it is my negative, minus from 2 to 1 del q over t for the process C is equal to 0. If you will see the same term, you can cancel those terms. Then I think these terms, what term can be cancelled, guys? PB, it is 2 to 1 and it is 1 to 2. So please write, please see this, that everything is clear or not. Everything is what I made. It is A to C now. The second term will be A to C. This will be A now. Yeah, this will be. Okay. So 1 to 2, this term and this term gets cancelled. I can write this. Please let me know. Can I write this or not? From 1 to 2 del q over t for the B process is equal to 2 to 1 del q over t for the C. Can we write this? Please let me know, guys. Can I write this? Yes or no? If I can write this, then please let me know so that I can comment some points about this. Okay, this is the expression. First question is, can we write this? Second question is that by writing this, what statements can be made about this? Tell me. What statements can be made on this? What I can say about this? Entropy is point function. Very good. Very good, Anushka. So these mathematical terms are saying that this ratio del Q over T for the process for the path B and for the path C. So we have these three paths. So del Q over T ratio is the same for path A and same for path C. What is the meaning? The meaning is that del Q over T is not the path function. Only del Q is my path function. Only del Q is my path function. But del Q over T is not my path function. It is my point function. It is my point function, right? So about this ratio, I can write about this ratio. So this actually what statements I can write over del Q over T about this. First is it is my point function, or you can say the state function. It is my state or point function. It means that it is depend upon the initial and final point. Yes or no? And secondly, if it is point or it is state function, then it is exact differential. Right? Or what we can it is if all the point function or all the state function are extensive property. So this ratio is state function or point function. This thing is exact differential. This thing is extensive property. This ratio is increasing if we increase the Q. This ratio is decrease if we decrease the Q. This ratio will be 0 if there will be no heat transfer. All the things are matching with a property which we defined earlier. That is my entropy. That is my entropy. That it is my thermodynamic property. If it is thermodynamic property, all the properties are point function first. Also, it is increased or decreased by it is increased by the supply of heat and it decreased by the rejection, or it will remain constant with no heat exchange. So all these things are matching with the entropy. So this ratio will be termed as entropy. Del Q over del T is equal to the change in the entropy. I hope that it is clear to you. I hope that it is clear to you. Right? Okay. So again, that it will increase if we supply the heat. It will decrease by rejecting heat. It will remain constant when there is no heat exchange. Right? See, if my ds is equal to del Q over T, if it is 0, it means that ds is equal to 0. ds is mean what? It is my change in the entropy. Yes or no? It means that my S1 is equal to S2, means the entropy will be constant. There is no change in the entropy actually. It is my extensive property, guys. It is my extensive property, and it is denoted by the entropy is denoted by the capital S. And it is my extensive property, right? If I want to make it intensive property, how I can make its intensive property? It is my specific entropy. Specific entropy, right? Specific entropy means entropy divided by mass. As I already told you, that any property defined per unit mass is called specific property. So it is specific entropy means the entropy divided by mass, and the specific property is always denoted by the small s. It is always denoted by the small s, right? It is clear to you. And its units are, if it is you can say entropy per mass, then it is my joule per kg per Kelvin or It is joule per mole per Kelvin. Okay, and for capital S unit is, for capital S its unit is joule per Kelvin. Joule per Kelvin. Yes or no? Am I clear with this? Am I clear with this? Please tell me that am I clear with this or not? So please let me know that you are clear with this or not. So in short, if I'll say about the entropy is that, what is that? See, if I'll sum all these things, then about the definition, right? About it's about entropy and maths. Definition is basically measurement of randomness, right? Unit is joule per Kelvin. It is increased if Q is increased, if decreased if Q is decreased, and change is zero if Q is, means that the heat transfer is zero. How to calculate the entropy from the maths? It is del Q is equal to TdS. Just remember this equation. This will be important for us. Del Q is equal to TdS. Okay, this is all about the entropy, guys, right? Means it's not all about the entropy, it is all about the basic part of the entropy, the basic things about the entropy. Okay, so it is my specific entropy, means it's per unit mass, right? If I'll write this ds, d small s, then I can write that per unit mass of the heat. It means that the, what is q is equal to capital Q divided by m. Okay, yeah, del Q over T, right? And for closed system, guys, can I write this? Can I write this that del Q is with the help of the first law? I can write it as my nothing but it is my du plus pdv, right? And divided by T, right? For closed system, we can write this. Yes or no? So what is my ds? ds is equal to, if you'll write, it is my du over T plus pdv divided by T. Okay. Now further, if we solve, du can be write as cv dt divided by T plus p by T can we can write p by T, sorry, what it is, p by T is r by v. pv is equal to for rt, right? It is my r by v T. Okay, done. If I'll integrate this thing ds from state 1 to 2, then it is equal to integration cv dt over T from 1 to 2 plus r is common dv over v from 1 to 2. It is equal to s2 minus s1, or you can say it is my delta s is equal to cv dt over T. Integration is ln t2 over t1 plus r ln v2 over v1. This is a one method to calculate the entropy change. So if we have, let's suppose you have any two state, it is 1, it is 2, and the process going from 1 to this 1 to 2, and question is asking about what is the entropy change when you use this formula. make sure that in the question there should be a data of C P1 T1 T2 V2 T2, right? So question can be given, question can give you any data. It can give you the VT data, it can give you the PV data, anything है ना, वो मर्जी है क्वेश्चनर की. So if you have the VT data, then use this formula. If you have VT data, if you have V1 T1 and if you have V2 T2, then you can say easily you can calculate the change in the entropy, guys. Otherwise you cannot calculate it. Am I clear with this or not? Am I clear with this or not? It's clear to you? It's clear to you, guys? It's clear to you? So please write it, and for today's it's enough. That's it. That's it for the today's class. So we will resume this topic in the next class. Okay. So as I told you at the start of the class that due to some reason I couldn't start the class at 12 o'clock. But yeah, in the next class we will resume this topic, and this entropy discussion will be continued. Okay. So I hope you enjoyed the class, guys. I hope that you enjoyed the class, you learned so much things, but still if you haven't read it, you can ask to me on the Telegram channel. Yes, as you know that we are doing this, or you can say we are doing this preparation from zero to the level which is above the, you can say the gate. You can say that that you can solve any difficult question of the gate after the completion of the lectures, right? We are with you, we are 24/7 with you. Just share your doubts and do your hard work, guys. Do not think about anything, just give this year to the gate, right? Forget about the functions, forget about everything, forget about the every, you can say the things which is going around you, and it can be anything. I hope you can understand. Just hold those things for 1 year, and it worth it. I'll tell you, it worth it. Just give your proper, just give your, you can say 100% energy to this examination. This examination will pay you, and it's my experience actually. That's why I'm saying this, right? So this exam can give you a lot of things, right? You can, whatever you think, this exam can give you those things, guys. But you have to be very patient, you have to be very consistent, you have to be very hard working person, right? And this is the demand of this examination. Okay. Thank you so much. Bye bye and take care. Let's meet in the next class, guys.